Hello, students who are still preparing for your paper 3 tomorrow. This is the video to help you in answering questions in your chemistry paper 3. What are the questions that you have to prepare for chemistry paper 3? Here is the list of questions which you can take a screenshot of them, and so you know what to prepare for your paper 3. These are the questions they always ask you in the paper 3. So first, presenting data is same like collecting data. Based on the experiment given, you carry out the experiment, you have to collect the data, you record down the data. They will want you to put it into a table form, maybe plotting a graph, doing some calculation, things related to the data, related to the result. Okay, reading. The second type of question is variable. The three types of variables, which everybody knows about it. Hypothesis, relationship between your MV and RV, responding variable and manipulated variable. Observation, what you observe during the experiment. Inference, explanation, a small explanation for the observation. Hey, why do I see this? I have to give one explanation. Number 6, operational definition is the question that students always ask me how to do. For chemistry, you have to write a sentence telling them what you did in the experiment and then what you observed. That means what you did and then what is the result, what is the outcome. Number 7, classification. They will give you a list of items and you have to classify them into 2 groups. Normally 2 groups, okay? Prediction. Predict what's going to happen next. What will happen to the value? Maybe the value will be higher or the value will be lower, or maybe no change. Explanation is like a paper 2 question. Okay, it's like a paper 2 question. Explain something, a theory, a concept. Okay, now we will go through some popular experiment that can come out in your paper 3. So for paper 3, remember, always read the question carefully because they will tell you what they are trying to do. So for example, this question, you see, they say, diagram 1 shows the apparatus setup. For the experiment 2, when you see the word 2, you have to start to be alert. Do what? To determine the voltage of the voltage cell. So basically, when they tell you what they are trying to do, that will be your responding variable. Okay, that will be your responding variable. I'm trying to find out the voltage of the cell. Okay, and then based on the procedure given, usually the last few points will give you the manipulated variable, which is the part they replace. You see, replace or repeat. They replace the zinc with iron nil. And then they replace the iron nil with magnesium again. So they are using different pairs of metal here. And sometimes if they give you a table like this, you can also most likely to have your MV and RV inside the table. Okay, so this is your MV, pairs of metal, RV, voltmeter reading or voltage of the cell. So trying to get MV and RV from the questions given. Okay, so do your experiment, record down the reading. Okay, if you don't know how to connect metals into voltmeter is something like this. I simply draw one. Okay, there is a negative terminal and also a positive terminal. You have to try to connect the 2 metals and then you put it into the solution until it gets a positive reading. You should get a positive reading. You shouldn't get a negative reading. Okay, when you got a positive reading, let's say somewhere around here. So it is telling you that, let's say this is my zinc and this is my copper inside the solution. Yeah. So this one, it shows you that the electron is flowing from here to here. This is how the electrons flow. It is like your voltmeter, the needle of your voltmeter deflect from here to here. It's like, ooh, to this right-hand side direction means the electron also flow like this. Okay, from zinc to the copper. If you get a negative reading, then you have to change law. Okay, like the zinc and copper, you have to switch like that. So here, based on your experiments, that using pair of zinc and copper metal, state one observation. You see, they will want you to give an observation. When I connect them and put them into the solution, what I see, the needle of the voltmeter deflects. It moved. So I write my answer. This is what I see. And then you see inference. You have to give explanation. Why the needle of the voltmeter will deflect? Why does it move? Okay, the reason is because it can be either one of the answer here. Electric current is produced. When there's electric current flow, then the needle will move along, right? It's like your battery got battery, then it will show the reading. EO value of zinc and copper is different. Different potential difference, then the needle will move. Okay, electrons flow from zinc to copper electron because there's movement of electron. So that's why you can see the needle of voltmeter deflects. And variables, as I told you in the questions, we got pairs of metal, voltage of the cell, or you can write it as voltmeter reading. Voltmeter reading also can. Fixed variable. Okay, what is fixed in this experiment? They never change the solution. Okay, they're always using sodium chloride solution. Same concentration and same volume. You always have to write these two together. If the volume and the concentration of the solution is the same, you have to always mention both. You can't just say a volume of sodium chloride solution. You have to write both, volume and concentration. If they both are the same, you have to mention both together. Okay, and then next, operational definition. So what I did, meaning of what I did is like the procedure that gets me the outcome, the result. After me doing this step, I will immediately see the result. Okay, so what I did here is when the two different metals are dipped into sodium chloride solution, this is what I do. When I put two different metal into the solution, or you can say different pairs of metal into the solution, voltmeter shows a deflection. So that's what I did, and that's what I observed, right? So voltmeter, the reading of the needles of voltmeter deflects is what I observed just now. So I just put it back. Okay, and then if you don't know how to get the sentence what I did, you can try to look for it. You can try to look for it in the procedure given. You see, dip the metals into sodium chloride solution. So that's what I did. Okay, operational definition. Next, what is this? Prediction. Change in the size of electron at negative terminal. So from your voltmeter, you should know okay, which one is connected to the negative terminal. Then here, this is aluminium. Okay, aluminium. Aluminium is the negative. Wait. Okay, when copper and Al are connected together, Al will be the negative terminal. So what will happen to the negative terminal? The negative terminal, the metal donates electrons to the other side. So it will become thinner because according to the equation, aluminium loses its electron to form Al3+. So my explanation will be aluminium atoms ionizes into the solution to produce aluminium ion by losing electron. Just like that. Classification. Classify ions in the sodium chloride solution into cation, anion. Remember to draw a table. Remember to draw a table for classification if the table is not given. And one more thing here. When you are taking reading, the voltmeter, you have to use 1 decimal place. That means if the answer is 1.0, if the reading is 1, you have to write 1.0. If you just write 1, no mark. 1.0. All right. Okay, so this is the voltage sum, just like that. These are the things that you have to study. And then here, hypothesis. This question doesn't have hypothesis. If they ask you hypothesis, this is how you give your hypothesis. The relationship between your MV and RV. The greater the difference of value of standard electrode potential, value of standard electrode potential is the EO, or we call it as potential difference. The greater the potential difference between the two metals, the greater the voltmeter reading. Okay, like that. So you have to remember how to write. Remember how to write, and if you are able to practice it, it's better that you practice it yourself. Okay, after chapter 1, it will be chapter 3. Heat of precipitation. They can ask you to do 2 heat of precipitation. Okay, and then you will be getting 2 readings, but the chances is very small for heat of precipitation. So here I will only show you, I will just go through this question quickly, showing you what they do. Mix 2 solution quickly, stir it, record down the reading. For heat of reaction must have initial and the highest temperature, the final, initial and final reading, so that you can tell whether the temperature increases or decreases by how much. A question here, observation for the experiment. So when you see observation in heat of precipitation, you can tell them what is the color of the precipitate you see. This reaction, they are reacting lead-2 nitrate with sodium sulfate. So that means they are going to produce lead-2 sulfate precipitate. It is white in color, so white precipitate is produced. Okay, ionic equation calculation. This one I skip. It's like a paper 2 calculation. You do Q equals to MC theta. M is the volume of the solution. So 2 solution, so it's 50 plus 50. C, specific heat capacity, 4.2. And this is the change in temperature, 4.5. Then you are going to get 1.89 kilojoule. To calculate the heat of precipitation, Q over mole. Q is the value you calculated just now, 1.89. Divide by number of mole, 0.01. And then you will get negative 189 kilojoule per mole. Energy level diagram. Okay. Heat of displacement definitely has a much higher chance than heat of precipitation. So this one, take note, are very important as well, heat of displacement. Okay. You see, it shows apparatus setup used in experiment to determine heat of displacement. That means what? This is your RV, heat of displacement. Experiment 1, they are using magnesium powder. Experiment 2, they are using lead powder. Both added into the same volume and same concentration of copper 2 nitrate solution. So that means this will be my fixed variable, volume and concentration of copper 2 nitrate solution. Okay, so you own self carry out the experiment and then record down the reading. For thermometer, it is the same, 1 decimal place for thermometer. Constructing a table to put in your data. Okay, there is no specific format. Okay, as long as it looks nice, then can already. People can understand what are you trying to present from the how you present your data, then can already. Okay, So next variable, you see, they are using magnesium and lead. So they are using two different types of metal. They are right types of metal. Or you can just write magnesium and lead like that. Tell them specifically what are the two different things they are using. Okay. Easier way will be types of metal, responding variable, heat of displacement. For all kind of heat of reaction, responding variable is always the same. Heat of displacement, heat of precipitation, heat of combustion, heat of neutralization. Okay. Constant variable. This is what we mentioned just now, volume and concentration of the copper 2 nitrate solution. So it's not very hard. Hypothesis. The more electropositive the metal used to displace copper from copper 2 nitrate solution, the higher the heat of displacement. So when I use a more electropositive metal, magnesium, the change in temperature is 35. When I use lead, I got a change in temperature of 21, which is lower. So this is my hypothesis. The more electropositive the metal, so this is my MV, and then the higher the heat of displacement, my RV. Based on the experiment 1, state 2 observation. For heat of reaction, other than temperature change, for heat of reaction, like this heat of displacement, copper 2 nitrate reacting with magnesium, it forms magnesium nitrate and copper. You will see a brown solid form. Blue solution turns into colorless, or there is another observation, which is the polystyrene cup becomes hot or warm. So observation is not just what you see. It can be what you feel also. When you touch it with a hand, you can feel hot. Okay. Inference based on your experiment. So if I'm giving this as my observation, why do I see brown solid? The answer is copper 2 ion has reduced to copper atoms. That means the brown color substance is copper. Blue solution to colorless, same explanation. Cu2 plus has turned into Cu. If this is my observation, my inference can be the reaction is exothermic. That's why the cup will become hot. So this is what you can answer for heat of reaction. Next, operational definition. So what do I do in this experiment? I place a more electropositive metal into copper 2 nitrate solution. And then thermometer reading increases. This is what I see. Okay, the temperature increase. That means it's showing that it is an exothermic reaction. Thermometer reading increases. Don't write, never write temperature increase. Temperature increase is not an observation. It should be thermometer reading because you see the reading. You can't see the temperature around you. Okay, calculation. Nothing special here. Energy level diagram. It's like a paper 2 question. Predict the heat of displacement of copper by zinc. If we are using magnesium 147, zinc is less electropositive. Zinc is placed below magnesium. Then the heat of displacement, the value will be less than or lower than 147. All right. Classification. Just like that. Now, heat of neutralization. Same thing lah. You see, in the experiment to compare heat of neutralization by using two types of acid, nitric acid and ethanoic acid. By the way, these questions I'm using here is the older syllabus one. But then the question they ask you is the same. Variables, hypothesis, all this. Your one should come with procedure. Okay, so I carry out the experiment, recording the readings, putting them into a table, giving hypothesis. When a strong acid reacts with strong alkali, we will get a much more higher heat of neutralization. But if you are using strong alkali with weak acid, we are going to get a lower heat of neutralization. So the things that we change here is the types of acid, strong acid and weak acid. One strong, one weak, so we call it as type of acid. What are we trying to find out? Heat of neutralization. Fixed variable. The potassium hydroxide solution is the same for all the experiment, 1 and 2. So I write volume and concentration of potassium hydroxide solution. 3 observations that you can obtain from the experiment. So 1, polishing cup becomes hot. Colorless solution is formed because KOH and ethanoic acid produces salt and water. The salt produced, which is potassium, HCOOK, potassium ethanoate is a colorless solution. You will be able to see because you carry out the experiment on your own. Reading of thermometer increases. Okay, just like that. Inference, thermometer reading increases. Polishing cup becomes hot. The reaction between ethanoic acid and sodium hydroxide is exothermic. So the questions are all very similar. Calculation, you see, calculation again. Relationship between type of acid, value of heat of neutralization. Explanation. So this is actually my hypothesis. Reaction between strong acid and strong alkali produce a higher heat of neutralization than weak acid and strong alkali. Why? Because weak acid ionizes partially in water. So some of the heat energy released is used to further ionize the weak acid completely into water. So this is what I mean by the paper 2 explanation question, this one. Okay. Then operational definition. So what I did, I add acid into potassium hydroxide solution. And then what I got? Thermometer reading increases. Based on experiment set 2, predict the change in temperature. If potassium hydroxide is replaced by ammonia solution, if we change a strong alkali to weak alkali, you see, experiment 2. How come it's 10 here? I see it wrongly already. Okay, the change in temperature for experiment set 2 is 10 degrees Celsius when a strong alkali and a weak acid. If we change it to both weak, then the value will be lower. So less than 10 degrees Celsius. Heat release is lower. Okay. Classification, strong and weak acid. Then yeah, that's all for chapter 3. So now we will be going back to the form 4